Hello viewers, welcome back to another section of my tutorial. Kindly subscribe if you haven't pressed the subscribe button. Please follow the video to the end so that you get understanding of everything we're going to do today. So it's a differentiated function y is equal to length of the expression, length of another expression, sine of another expression, s squared. So this is a composite function having 1, 2, 3, 4 functions combined. So let's see how I'm going to differentiate this function stepwise. Please follow as I go through the various stages to solve this problem. So let's start. So we have y is equal to this. To handle chain rule or composite function, you take the least or the smallest function from the left side as you move towards the bigger one. So here we take the s squared and represent s squared with u. Let's say u is equal to s squared. Then after you find the u over the x, and that will give us 2x. You put this one down. Now we've represented s squared with u, so this whole function is going to be sine u. This whole part will be sine of u. Now let's represent sine of u with, let's say, v. So let's v to be equal to sine of u. Now what you're going to find is the v over the u, and that will give us cos u. So we now know that sine of s squared is represented by what? V. The whole here is represented by v. So we'll be left with length of v. So let's say p to be equal to length of v. So the p over the v is going to be, here we differentiate v over the v itself. We get 1 over v. We put it down. Now our function is going to be y is equal to length of p. And finally the y over the p will be equal to, when you differentiate p, which is 1 over the p itself. That is how to find the derivative of every length function. At this point, let's go back to what the question asked us. We are going to find the y over the x. So this will be equal to, we bring out the y, then in the chain rule that we did, or in the various derivative, the y was over the p, so we bring the p down, then times, we bring the p up, all over the v, then we bring the v up all over the u as we see, then finally the u up all over the x. We multiply all these functions together. So the y over the p is 1 over p, make our substitution, then the p over the v is 1 over v, then the v over the u is cos u, then finally the top one is 2x, the u over the x is 2x. We have to multiply everything here. Wherever we see p, we put the necessary, or we make the necessary substitution. So p is length v, so we are going to have 1 over length of v times 1 over, our v is equal to sine u, so sine u times cos, our u is s squared, so cos s squared times 2x. Let's move further to represent v with its variable that we use to represent. So v is sine of u, so we are going to have 1 over length of sine of u, length of sine of u, times 1 over u is equal to s squared, so sine s squared times cos s squared times 2x. Then also u is s squared, so we have 1 over length of the expression sine s squared times 1 over sine s squared times cos s squared times 2x. We multiply everything, you have 2x cos s squared all over sine s squared, multiplying length of the expression sine of s squared, and that becomes our derivative for this composite function. Thank you for watching. Kindly subscribe so that you get notified when I post related tutorial videos. Thank you.